Segments of New Proofs for the Existence of God by Father Robert J. Spitzer. When we speak of a beginning, we stand at the threshold of physics and metaphysics. Even though science cannot be validly used to prove a metaphysical claim, it can be used to maintain as highly probable a limit to physical reality. This scientific evidence for a beginning can be combined with a metaphysical premise, such as, from nothing, only nothing comes, to render a metaphysical conclusion that there must be something beyond physical reality which caused physical reality to exist. There are other indications of supernatural causation arising out of contemporary cosmology, besides the implications of a beginning, namely, the occurrence of several cosmological conditions essential for the development and sustenance of any life form, that seem at least prima facie to be highly improbable. These seemingly highly improbable conditions can imply an element of supernatural fine-tuning if no satisfactory naturalistic explanation can be found for them. This evidence is discussed in Chapter 2. The existence of a creator does not rest on scientific cosmological evidence alone, of course. There would be sufficient rational grounds to affirm the existence of a creator without modern science. Chapters 3 through 5 presents 3 different philosophical proofs for the existence of a creator. But the purely philosophical and metaphysical arguments, and the arguments based on the findings of modern science, can be seen to complement and corroborate each other. This complementarity and corroboration constitute a network of evidence. John Henry Newman termed such a network of evidence an informal inference, i.e., reaching a conclusion by considering the accumulation of converging antecedent probabilities. For Newman, truth claims did not have to be grounded in an infallible source of evidence or in a strictly formal deduction. They could be grounded in the convergence of a multiplicity of probabilistic evidential bases. Certitude is not grounded in one base alone, but in a multiplicity of likely or probable evidential bases. Thus, even if one of these bases undergoes modification, the certitude intrinsic to the convergence remains intact. The purpose of this book is to set out the specific evidential bases for this convergent probability in which science plays an integral role. One might ask, what if the universe keeps undergoing cycles in the future? The ratio of cosmic radiation to starlight would keep growing without limit. But that would not be because the amount of cosmic radiation would keep growing without limit. Rather, at some point the amount of starlight being produced would go to zero. The universe would not keep making stars forever. At some point, the fuel available for stars would have been used up, so to speak. Personal note: starlight of previous cycles accumulate into the black body radiation. Therefore, if there have been many cycles, CR should have a higher weight, but it is only one. In 2003, all 3 joined together to formulate an elegant proof of a boundary to pass time in all cosmologies where the average Hubble expansion is greater than 0. This proof is not dependent on the weak energy condition which allowed for possible exceptions. They formulated their findings as follows. Our argument shows that null in time like geodesics are, in general, past incomplete in inflationary models, whether or not energy conditions hold, provided only that the averaged expansion condition H0 hold along these past-directed geodesics. This is a stronger conclusion than the one arrived at in previous work, in that we have shown under reasonable assumptions that almost all causal geodesics, when extended to the past of an arbitrary point, reach the boundary of the inflating region of spacetime in a finite proper time. Even though this amounts to what Craig and Sinclair call a gross deconstruction of the notion of time, they criticize it from the standpoint of physics. The Aguirre-Grattan scenario denies the evolutionary continuity of the universe which is topologically prior to T and our universe. The other side of the Sitter space is not our past, for the moments of that time are not earlier than T or any of the moments later than T in our universe. There is no connection or temporal relation whatsoever of our universe to that other reality. Efforts to deconstruct time thus fundamentally reject the evolutionary paradigm. In any event, few physicists would take this idea as all. They would dismiss it as utterly unphysical. Many other scenarios for a universe with no beginning have been proposed. There is no point in trying to do an exhaustive survey. They all run afoul of the kinds of arguments we have been discussing, based on either geometrical considerations such as the BVG theorem or the second law of thermodynamics. Just to take one more example, there is a proposal by a physicist named Bojewald for a universe with no beginning. It is based on a theory of quantum gravity called loop quantum gravity. The details of Bojewald's proposal are not important for our purposes. What is instructive, however, are the comments on it by Sean Carroll, a leading Bojewald uses some ideas from loop quantum gravity to try to resolve the initial singularity and follow the quantum state of the universe, past the bang back into a pre-existing universe. If you try to invent a cosmology in which you straightforwardly replace the singular Big Bang by a smooth Big Bounce continuation into a previous spacetime, you have one of two choices. Either the entropy continues to decrease as we travel backwards in time through the bang, or it changes direction and begins to increase. Sadly, neither makes any sense, if you are imagining. Carroll is referring to the fact that the entropy of our universe just after the Big Bang was fantastically low. It was so low that the odds of it being so low, if it was just a matter of chance, have been estimated to be a mere 1 in 10 to the 10 to the 123 by Roger Penrose. For perspective, there are 10 to the 80 atoms in the universe. It has been argued by the particle physicists Banks and Fischler that during such a collapse the rapidly changing spacetime would have excited and amplified random quantum fluctuations, in such a way that entropy would have been driven to very large values rather than small ones. This makes it even more difficult to account for the fantastically low entropy just after the Big Bang. Personal note: in bouncing cosmologies, contraction amplifies quantum fluctuations and increases entropy rather than reducing it. I have a problem with all else cyclic cosmologies. The collapsing phase of these models always have a time-dependent Hamiltonian for the quantum field fluctuations around the classical background. Furthermore, the classical backgrounds are becoming singular. This means that the field theories will be excited to higher and higher energy states. High energy states in field theory have the ergodic property. They thermalize rapidly, in the sense that the system explores all of its states. Willy Fischler and I proposed that in this situation you would again tend to maximize the entropy. We called this a black crunch and suggested the equation of state of matter would again toward p rho. It seems silly to imagine that, even if this is followed by a re-expansion, that one would start that expansion with a low entropy initial state, or that one had any control over the initial state at all. If theorists are to construct a cosmological model which does present an alternative to a beginning, they will have to meet at least 4 major conditions which have been presented in various places above. Assure that the model avoids the first fundamental problem, inconsistency with cosmological observation. Assure that the model avoids the second fundamental problem, internal inconsistency and non-workability. Assure that the model is not subject to the BVG theorem. With respect to a bouncing proposal, assure that the model avoids the buildup of entropy, Tolman's limit, and Carroll's paradox of extreme fine-tuning for no apparent reason. So far, no models have succeeded in doing all these things. Accomplishing them in the future will be quite difficult because of the extensive general applicability of the BVG theorem and the second law of thermodynamics. Personal note: common causes for rejecting a past infinity cosmology model is that the time direction is reversed and second law of thermo violation. This second metaphysical premise dates back to the time of Parmenides. It may be summed up as follows: from nothing, only nothing comes. If we don't put any content into nothing, then nothing will not mistakenly refer to something. It will not mistakenly be thought to have characteristics do something or be somewhere, etc. Nothing is nothing. There is no such thing as nothing. To say anything else argues the most fundamental of contradictions. We may now proceed to our conclusion, combining a first premise from physics and a second premise from metaphysics. If there is a reasonable likelihood of a beginning of the universe, and if it is a priori true that from nothing, only nothing comes, then it is reasonably likely that the universe came from something which is not physical reality. This is commonly referred to as a transcendent cause of the universe, or a creator of the universe. This leads to our final topic, which revisits our starting point. Recall John Henry Newman's idea of an informal inference, namely, reaching a conclusion by considering the accumulation of converging antecedent probabilities. We have shown in this chapter that the preponderance of cosmological evidence points to a beginning of the universe, which, when combined with a metaphysical premise, implies a transcendent cause of the universe. This probable conclusion combines with an argument given in Chapter 5 from the philosophy of mathematics, which demonstrates the same conclusion. Indications of supernatural design in contemporary Big Bang cosmology. Since the time of Aristotle, philosophers have given considerable thought to purpose in nature. From Aristotle, so what should prevent the parts in nature too from coming to be of necessity in this manner? For example, the front teeth of necessity coming out sharp, and so fit for tearing, but the molars broad and useful for grinding food, not however for the sake of this but by coincidence. Things by nature come to be either always or for the most part, but none of those by luck or chance do so likewise. There is then final cause in things which come to be or exist by nature. St. Thomas Aquinas used this notion of purpose as the basis of a proof for God's existence. This insight was considered seriously in post-Renaissance thought by philosophers such as William Paley. St. Thomas Aquinas, in his Fifth Way, expressed this insight as follows: "The fifth way is taken from the governance of the world. We see that things which lack intelligence, such as natural bodies, act for an end, and this is evident from their acting always, or nearly always in the same way, so as to obtain the best result. Hence it is plain that not fortuitously, but designedly do they achieve their end. Now whatever lacks intelligence cannot move towards an end directed by some being endowed with knowledge and intelligence, as the arrow is shot to its mark by the archer. Therefore some intelligent being exists by whom all natural things are directed to their end. And this being we call God." Despite a long period of criticism from Descartes to Nietzsche, the intuition of design worked its way back into both philosophical and scientific thought in the mid-20th century as evidence began to accumulate for the finitude of our universe in both mass and time. But suppose I had found a watch upon the ground, and it should be inquired how the watch happened to be in that place. I should hardly think of the answer which I had before given, that for anything I knew, the watch might have always been there. Yet why should not this answer serve for the watch as well as for the stone? Would any man in his senses think the existence of the watch, with its various machinery, by being told that it was one out of possible combinations of material forms, that whatever he had found in the place where he found the watch must have contained some internal configuration or other, and that this configuration might be the structure now exhibited, viz., of the works of a watch, as well as a different structure. Prior to the development of revised Big Bang cosmology, Albert Einstein intuited the extreme improbability of an anthropic universe. You find it strange that I consider the comprehensibility of the world as a miracle or an eternal mystery. Well, a priori one should expect a chaotic world which cannot be in any way grasped through thought. The kind of order created, for example, by Newton's theory of gravity is of quite a different kind. Even if the axioms of the theory are posited by a human being, the success of such an enterprise presupposes an order in the objective world of a high degree which one has no a priori right to expect. That is the miracle, which grows increasingly persuasive with the increasing development of knowledge. Since that time, developments in astrophysics have substantiated Einstein's intuition in remarkable ways. Determination of the age of the observable universe, determination of the distribution of matter and energy in the universe, visible matter, and dark energy, determination of the visible mass of the observable universe, and the identification of most universal constants. These developments reflect the universe's intrinsic parameters, which were not recognized by Newton and the modern philosophers who were heavily dependent upon him. Prior to Einstein's publication of the general theory of relativity, one could have thought that supernatural design was completely unnecessary, because it was believed that the universe existed for an infinite amount of time, with an infinite amount of space and an infinite amount of interacting content. Therefore, there would have been an infinite number of trees to bring about virtually any degree of complexity. Standard Big Bang cosmology totally changed these postulates and reduced the total number of trees in the observable universe to a very finite number, that is, 13. 7 billion years, 365 days, 24 hours, 60 minutes, 60 seconds, 10 of cubi kilograms of visible mass in the observable universe, 10 phi, reduction to minimum units of mass. This is approximately equal to 10 squared phi total possibilities for interactions of mass energy expressed in minimum units of mass and time. This is a large but very finite number. When it is compared with the enormous odds against a low-energy universe emerging from the Big Bang Penrose number, it is absolutely minuscule. This comparatively small number of total possible mass-energy interactions in the universe for all time revealed the extreme improbability of high degrees of complexity arising out of the universe by pure chance. This produced a remarkable openness on the part of some physicists to the prospect of supernatural design. Contemporary physicists such as Arno Penzias, Roger Penrose, Owen Gingerich, John Polkinghorne, Fred Hoyle, Fournier, and Paul Davies have since adduced the plausibility of a designing intelligence from the evidence of contemporary physics. In God and the New Physics, Paul Davies notes, the numerical coincidences could be regarded as evidence of design. The delicate fine-tuning in the values of the constants, necessary so that the various different branches of physics can dovetail so felicitously, might be attributed to God. It's hard to resist the impression that the present structure of the universe, apparently so sensitive to minor alterations in the numbers, has been rather carefully thought out. Such a conclusion can, of course, only be subjective. In the end, it boils down to a question of belief. Is it easier to believe in a cosmic designer than the multiplicity of universes necessary for the weak anthropic principle to work? Perhaps future developments in science will lead to more direct evidence for other universes, but until then, the seemingly miraculous concurrence of numerical values that nature has assigned to her fundamental constants must remain the most compelling evidence for an element of cosmic design. Davies, 1983, page 189. This chapter will summarize some of the results upon which physicists base their belief in design by supernatural intelligence. It will then respond to the major alternative to supernatural design forwarded by some contemporary physicists. The general form of the argument used by some physicists to justify belief in a supernatural designing intelligence may be set out as follows. The values of the universal constants controlling the interrelationship among space, time, and energy in the universe must fall within a very narrow closed range in order to allow any life form to develop. But the possible values that these universal constants could have had that would have disallowed any form from developing are astronomically higher. Therefore, the odds against an anthropic condition occurring are astronomically high, making any life form exceedingly improbable. This makes it highly unlikely that the conditions for life in the universe occurred by pure chance, which begs for an explanation, physical or metaphysical. Universal constants. If a universe is not to be random and chaotic, the interactions and interrelationships among space, time, and the different kinds and emissions of energy would have to occur through fixed or virtually fixed, long-term parameters. These quantitative parameters control virtually every interaction in the universe, and they are integral to the equations of physics. The extreme improbability of our anthropic universe. The first instance is given by Roger Penrose, who shows the exceedingly high improbability of a low-entropy condition arising out of the Big Bang. Note that a low-entropy condition occupies a very small volume of the total phase space of possible universes which could have arisen out of the Big Bang, while high-entropy conditions occupy a much larger volume of the phase space of possible universes. Therefore, Penrose can determine the improbability of this essential low-entropy condition by calculating the ratio of the total phase space volume of possible universes for a creation event and the phase space volume of a universe. compatible with the second law of thermodynamics, low entropy. A phase space is a space in which all possible states of a system are represented, with each possible state of the system corresponding to one unique point in the phase space. The phase space of a single particle can be represented by 3 position coordinates and 3 momentum coordinates, so that the phase space is a 6-dimensional representation of that single particle. Penrose begins by calculating the total entropy of our universe, which represents the logarithm of the total phase space volume of possible universes in a creation event. The total entropy of our universe is equal to the total number of baryons in the universe, the entropy per baryon, which yields a total entropy of 10 a squared cubed. Since 10 a squared is the logarithm of the total phase space volume, the total phase space volume of possible universes for a creation event is the exponential of 10 squared cube, namely 10. Now Penrose calculates the phase space volume of our anthropic universe and then finds the ratio between the total phase space volume of possible universes calculated above and the phase space volume of our anthropic universe. He does this as follows. How big was the original phase space volume W that the Creator had to aim for in order to provide a universe compatible with the second law of thermodynamics and with what we now observe? It does not much matter whether we take the value W10 or W10, given by the galactic black holes or by the background radiation, respectively, or a much smaller figure, which would have been the actual figure at the Big Bang. Either way, the V to W will be closely VW10. This now tells us how precise the Creator's aim must have been, namely to an accuracy of 1 part in 10. He summarizes as follows. In order to produce a universe resembling the one in which we live, the Creator would have to aim for an absurdly tiny volume of the phase space of possible universes, about 1/10 of the entire volume for the situation under consideration. The second instance concerns the interrelationship among the gravitational constant, weak force constant, and the cosmological constant with respect to the rate of acceleration of the universe as a whole. As Davies notes, if G or differed from their actual values by even 1 part in 10 Pfeiffer, the precise balance against Laber would be upset, and the structure of the universe would be drastically altered. A third instance of improbable anthropic conditions concerns the strong force constant. This constant cannot vary more or less than 2% from its current value without rendering impossible the formation of hydrogen or any other element heavier than hydrogen. Either one of these 2 scenarios would have disallowed a life form from developing within our universe. Walter Bradley sums up Brandon Carter's research on this topic by noting, Brandon Carter in 1970 showed that a 2% reduction in the strong force and its associated constant would preclude the formation of nuclei with larger numbers of protons, making the formation of elements heavier than hydrogen impossible. On the other hand, if the strong force and associated constant were just 2% greater than it is, then all hydrogen would be converted to helium and heavier elements from the beginning, leaving the universe no water and no long-term fuel for the stars. The absolute value of the strong force constant, and more importantly, its value relative to the electromagnetic force constant, is not prescribed by any physical theories, but it is certainly a critical requirement for a universe suitable for life. A fourth instance of the improbability of anthropic conditions in our universe concerns the relationship between the gravitational and weak force constants on the one hand, and the neutron-proton mass and electron mass on the other. The value of the weak force constant in its relationship to the value of the gravitational constant guarantees a sufficient amount of hydrogen for solar power and water. Notes: slight variations from this would have given rise to a universe inhospitable to life. As Davies notes, it is at this stage that an extraordinary coincidence is discovered. First, it so happens that the neutron-proton mass difference is only a little greater than the electron mass, delta m. Second, the strength of the weak interaction is, apparently accidentally, related to the strength of gravities. Through G = e.g. c. 10. When these 2 numerical accidents are used in EQ, one obtains KTF delta MC squared. If KTF had been either greater than or less than delta MC squared, either hydrogen would have been absent from the universe, or diverse heavier elements would have been substantially limited. A fifth instance of the improbability of anthropic conditions concerns the gravitational constant in its relation to the electromagnetic constant and the ratio of electron to proton mass. These constants must have their precise actual values in order for stars with sufficiently stable energy to develop. Without these precise values, the vast majority of stars would have been blue giants or red dwarfs. A sixth instance of the improbability of anthropic conditions concerns the weak force constant and its relationship to the carbon atom. This constant must have a value similar to that in our universe if carbon is to be operative. Sufficient heat is required for carbon bonding to occur, the kind of heat that can only be provided by a supernova explosion. This same heat is also required for the production of iron and uranium atoms. As Davies notes, if the weak force had varied ever so slightly, supernovae would never have occurred, thereby depriving carbon atoms of the heat necessary for their production. We owe the presence of the carbon in our bodies, the iron core of our planet, and the uranium in our nuclear reactors to supernovae that occurred before the solar system formed. Without supernovae, Earth-like planets would not exist. If the weak interaction were much weaker, the neutrinos would not be able to exert enough pressure on the outer envelope of the star to cause the supernova explosion. On the other hand, if it were much stronger, the neutrinos would be trapped inside the core and rendered impotent. Either way, the chemical organization of the universe would be very different. A slight variation in the weak force, constant above or below its current value, would have prohibited supernovae explosions, which would, in turn, have prohibited the generation of carbon necessary for the development of life forms in our universe. A seventh instance can be adduced from the resonances of atomic nuclei. These resonances are dependent upon the precise values of fundamental constants as well as the generation of atomic nuclei through universal and stellar evolution. One of the most remarkable examples of this is the resonance of the carbon nucleus. Owen Gingerich shows that the precise resonance of the carbon atom necessary for its multiple bonding properties happens to coincide perfectly with the resonance of beryllium, helium, and oxygen. If this extremely remote coincidence had not occurred, then carbon would be extremely rare, and carbon-based life forms would not have emerged. Here the internal details of the carbon nucleus become interesting. It turns out that there is precisely the right resonance within the carbon to help this process along. The specific resonances within atomic nuclei are something like, except in this case the particular energy enables the parts to stick together rather than to fly apart. In the carbon atom, the resonance just happens to match the combined energy of the beryllium atom and a colliding helium nucleus. Without it, there would be relatively few carbon atoms. Similarly, the internal details of the oxygen nucleus play a critical role. Oxygen can be formed by combining helium and carbon nuclei. The resonance level in the oxygen nucleus is 0.5% too low for the combination to stay together easily. Had the resonance level in the carbon been 4% lower, there would be essentially no carbon. Had that level in the oxygen been only 0.5% higher, virtually all of the carbon would have been converted to oxygen. Without that carbon abundance, none of us would be here now. That Fred Hoyle, who, together with William Fowler, first noticed the remarkable arrangement of carbon and oxygen nuclear resonances, has said that nothing has shaken his atheism as much as this discovery. Though many other examples could be given, the above 7 are sufficient to show that slight variations in the actual values of our universal constants would have given rise to a universe incapable of sustaining any life form. If the values of these constants had not been built into the initial conditions of the universe would have probably emerged as a collection of black holes, or a universal black hole, a universe of high entropy, or a dispersion of weakly interacting particles, or a universe without hydrogen, or a universe without heavier elements, or a universe without carbon or iron, or a universe of blue giants or red dwarfs, all of which would have meant a universe incapable of sustaining any life form. Bruce Gordon concludes, It is clear that the string landscape hypothesis is a highly speculative construction built on shaky assumptions and requires meta-level fine-tuning itself. In view of this, and the apparent absolute beginning of the landscape, it does not seem to escape the implication of non-natural or supernatural design. This leads us to Fred Hoyle's observation. A common-sense interpretation of the facts suggests that a superintellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Prior to the existence of all space, time, matter, and energy, there was no universe to describe, and there were no physical laws or initial conditions that could have played a role in its genesis. Rather, all these things came into existence out of nothing, so a transcendent immaterial cause must necessarily have acted. IV. Inflation and cosmological fine-tuning. Inflation has also been used by some as a strategy for explaining the cosmological fine-tuning of our universe. The irony of this is that the inflaton field, which was invented as a reservoir of virtually unlimited energy for the explanation of horizon and flatness fine-tuning in the bubble universes it spawns through the decay of its false vacuum, requires exquisite fine-tuning itself. It is worthwhile considering whether the cyclic ekpyrotic scenario has the probabilistic resources to address the 1 in 10x fine-tuning of the Big Bang entropy of our universe. It does not. It is not an inflationary model, though it does involve dark energy, so it does not invoke an unending chaotic cascade of string vacua. Rather, each trillion-year cycle produces 10 Pfaffer to 10 Pfaffer Big Bang events, with opportunities for finely tuned entropy. This means that with each new cycle, there is at best a 1 in the formula below. Whatever else may be said, it is clear that the string landscape hypothesis is a highly speculative construction built on shaky assumptions and, even if taken seriously, requires meta-level fine-tuning itself, may be unequal to the task it is intended to perform, may ultimately be unphenomenologically untenable, and seems to contain the seeds for destroying science as a rational enterprise. Its prospects, therefore, are not promising. Given this sobering assessment, one wonders why the string landscape has provoked so much enthusiasm among cosmologists. Leonard Susskind-Kubu provides a revealing answer. If, for some unforeseen reason, the landscape is out to be inconsistent, maybe for mathematical reasons, or because it disagrees with observation. As things stand of now, we will be in a very awkward position. Without any explanation of nature's fine-tunings, we will be hard-pressed to answer the ID critics. Just so. VI. Conclusion. A closing reflection on the nature of mathematical physics is appropriate. Stephen Hawking has asked, somewhat poetically, what is it that breathes fire into the equations and makes a universe for them to describe? This question deserves a genuine answer. As a matter of logic, mathematical descriptions may have ontological implications, but they do not function as efficient causes, either metaphysically or materially. They are causally inert. When inflationary cosmology describes string vacua as tunneling into existence from absolute nothingness or from another vacuum state, or even when relativistic quantum field theory describes matter as popping out the quantum vacuum, neither mathematical construction provides an explanation, let alone an efficient cause, for these events. The belief that a mathematical description shows that the universe does not have and does not need a cause is both a non sequitur, it does not follow from the descriptions themselves, and an ontological category mistake. When landscape theorists like Leonard Susskind assert the existence of a landscape of possibilities giving rise to a megaverse of actualities, and suggest that this provides a mindless solution to the problem of fine-tuning, they completely ignore the fact that a virtually unlimited arena of mathematical possibilities cannot generate even one actual universe. The mindless multiverse solution to the problem of fine-tuning is quite literally physical non-starter. What the absence of efficient material causality in fundamental physics and cosmology reveals instead is the limit of scientific explanations and the need for a deeper understanding. When the logical and metaphysical necessity of an efficient cause, the demonstrable absence of a material one, and the proof that there was an absolute beginning to any universe or multiverse are all conjoined with the fact that our universe exists and its conditions are fine-tuned immeasurably beyond the capacity of any mindless process. The scientific evidence points inexorably toward transcendent intelligent agency as the most plausible, if not the only reasonable explanation. IB proof that hypothesis F must be false for any conditioned reality 1. If any conditioned reality is dependent on only a finite number of conditions for its existence, then there would have to be a most fundamental condition upon which the CR depends. For example, a quark or some other more fundamental conditioned reality would have to be the most fundamental condition upon which a CR, say a cat, depends. This temporarily ignores the possibility of a circular set of conditions which will be disproved in section I.D. below. 2. Hypothesis UR asserts that there are no unconditioned realities in all reality. This is equivalent to asserting that there are only conditioned realities. Therefore, the most fundamental condition for any conditioned reality would have to be a conditioned reality. 3. If we ignore the possibility of a circular set of conditions for the moment, then the most fundamental condition must be a conditioned reality whose conditions are not fulfilled. The last condition must have conditions because it is a conditioned reality, and its conditions cannot be fulfilled because it is the last or terminating condition. Therefore, the combination of and hypothesis UR requires that the last condition be a conditioned reality whose conditions are not fulfilled. But a conditioned reality whose conditions are not fulfilled is literally nothing. 4. If the combination of hypothesis UR and hypothesis F requires that the most fundamental condition be non-existent, then all conditioned realities hypothetically dependent on it would also have to be non-existent, in which case the conditioned reality would never exist. Therefore, no conditioned reality can exist under both hypotheses UR and F. Therefore, hypothesis F under hypothesis UR must be false for any conditioned reality in all reality. I see proof that hypothesis F must be false for any conditioned reality 1. According to hypothesis F, any conditioned reality is dependent on an infinite number of conditions being fulfilled for its existence. This means there is no most fundamental condition. 2. If there is no most fundamental condition, then the number of conditions upon which CR depends is always 1 plus more than can ever be achieved, and is therefore unachievable. 3. If CR depends on an unachievable number of conditions being fulfilled for its existence, in other words, if CR is dependent upon a dependent upon a dependent upon a dependent, ad infinitum, in order to come into existence it will never come into existence. Its conditions will never be fulfilled. 4. Therefore, no conditioned reality can exist under hypothesis F. Therefore, hypothesis F is false for any conditioned reality. ID proof that a circular set of conditions is false for any CR. It may at first seem that a circular set of conditions is an intermediate or alternative position to hypotheses F and F. As will be shown in a moment, it is not. Circular set of conditions means reciprocal conditionality, where CR depends CR for its existence, while CR depends on CR for its existence. It can be shown that CR's dependence CR's dependence, ECC, would not allow either to exist. But in order to show the fallacy of circular conditionality within the context of hypotheses F and F, I have chosen the following argument. 1. Let us suppose there is a circular arrangement of conditioned realities, which in turn is dependent on CR-bens, which is in turn dependent on CR3. There is an obvious similarity here to the uncaused cause argument, the second way of St. Thomas Aquinas. But I have refrained from using the word cause in the proof here because cause has been interpreted by various philosophers in very narrow ways. It would not be useful, for example, to view cause simply as one billiard ball striking another, or an aggregation of mass points. If it is useful to interpret the concepts in this chapter in causal terms, I could define proximate cause as a proximate fulfillment of a conditioned reality's conditions. First cause could be defined as the ultimate fulfillment of a conditioned reality's conditions by an unconditioned reality. These definitions are not restricted to pre-20th century views of physics and philosophy. By using the vocabulary of this chapter, proximate cause could refer to the collapse of a wave function to an eigenstate, the reorientation of motion arising out of irregular geometries of spacetime, plasma interactions, and even the creation of the entire universe by a reality outside of spacetime asymmetry. One may postulate any number of CRs in the circle that one wishes. The question is not how many conditioned realities are in the circle, but rather how many conditions each conditioned reality is dependent on in the circle. There are, again, two disjunctive options to respond to this question. Each conditioned reality is dependent on a finite number of conditions, or each conditioned reality is dependent on an infinite number of conditions. This is completely disjunctive. Therefore, if the circularity hypothesis is to be tenable, then one of these hypotheses must be true. If neither of the hypotheses is true, then the circularity hypothesis cannot be tenable. If it is postulated that the circle corresponds to hypothesis F, then there must be a last condition in the circle. Let us say that the last condition is CRC. The last condition would have to be a conditioned reality whose conditions are not fulfilled, in which case it would not exist. All other conditioned realities in the circle that depend on CRC would likewise not exist. The circle would therefore not be able to come into existence. Notice that this is simply a restatement of the disproof of hypothesis F in section I. Let us hypothetically entertain the other side of the disjunction, namely that every CR in the circle is dependent on every other CR an infinite number of times. This means that every CR in the circle is dependent upon an infinite number of conditions being fulfilled. Since an infinite dependence is unachievable, every CR in the circle would have to be dependent on an unachievable number of conditions being fulfilled. Again, the circle would not be able to come into existence. Notice that this is simply a restatement of the disproof of hypothesis F given in section I. See. Inasmuch as a circle must imply either that each conditioned reality is dependent on a finite number of conditions, or that each conditioned reality is dependent on an infinite number of conditions, because there is no last condition, and since both sides of this disjunction are false, i.e., will not allow any of the conditioned realities within the circle to exist, then a circle of dependent conditions cannot explain the existence of any of its constituents, and therefore cannot represent a real state of affairs. I.e., there must exist at least one unconditioned reality in all reality 1. If hypotheses F and F are both false for any conditioned reality, and if hypotheses F and F represent the whole range of possibilities for any conditioned reality, and if a circle is not an alternative position to hypotheses F and F, then no CR can exist under either or both hypotheses. 2. If no CR can exist under either or both hypotheses, then there cannot be only conditioned realities in all reality. 3. Therefore, by disjunctive syllogism, there must be at least one unconditioned reality in all reality. To deny this would require affirming either hypothesis F or both. Affirmation is absurd, for nothing, not even this writer, would then be able to exist.